Well, then, welcome. I hope that I will be on the expectations. Before I go to the next slide, let me just introduce you a bit this picture. This is Munich. This is where I'm coming from. This is where I've been living in the last 8 years. This tower is where my boss is sitting. This building here is where you can go and visit fancy cars, free entrance. Here you have the museum. Here you can pay and visit some other cars, old cars. And here is where we are building some cars that are built in Munich. Okay, let's start a bit about me first. You can find me in GitHub and Twitter or X, not on Mastodon yet. I've been working in C++ since 2011. And I've been in safety critical systems since I moved to BMW. And basically, it's like, since then, it's the only time that I've been doing safety critical systems. I didn't do it outside BMW. And nowadays, I represent BMW at the MISRA C++ working group, and also at the C++ committee meetings since, let's say, COVID. That was not as a good way to start. That was quite hard, but going there. Okay, first disclaimer about me. I'm not a functional safety expert. Just don't take anything for granted that I say regarding functional safety. I'm not a static analysis expert. I don't want to go down that path. I'm also not a MISRA expert. I do my best. I participate in the working group. When a rule doesn't make sense, I try to improve it. I'm there, but I joined recently, and I don't consider myself an expert on that. Okay, then why I'm here? Basically, like I'm a technical lead of a software development team, and we have to deal with functional safety. We have to deal with static analysis. We have to deal with MISRA every single day. And I think that this gave me a perspective that a functional safety expert doesn't have, or a static analysis expert doesn't have, or a MISRA expert doesn't have. It's like on the everyday job. And basically, today it's a bit about that. Like it's from a software developer to a software developer, and I just want to show you my point of view. But don't take anything for granted before you, check your experts. And also just as a member of MISRA working group, that's always like important. I'm not representing MISRA here, like everything that I say, it's my opinion, my word. Okay, now we know about me. I would like to know a bit about you. How many of you use the static analysis tools? Good, I like it. Okay, how many of you know about MISRA? Okay, quite a lot, good. How many of you have to deal with MISRA? I see less than before. Some are lucky. They know and they don't have to deal with it. Okay, now let's go about to the talk. And I would like to introduce this talk just starting from the title and grab the different parts. Because one thing that is missing is kind of fundamentals. And for me, this talk is about like fundamentals. I hope that I will not disappoint anyone. I don't want to go deeper into MISRA. I don't want to go into specific rules. That's not what is the talk about. It's more about building some intuition on exactly what the title is saying, how to deal with the static analysis findings with MISRA. And let's start with the static analysis. Okay. What I have to say, I think we can skip it a bit faster, but let's remember a bit. To talk about what static analysis, I found this quote. I like it quite a lot. Computer programs can be checked for errors statically and dynamically. And then we have a static analysis, looks for a structural and semantic faults in programs. Dynamic analysis affirms proper operation and helps identify errors. And here would come my first question. When do you think that this quote is from? Year, approximately. 60s, 70s, 80s, 90s, 2000, 2010, 2020, 1800, I don't know. It's from 78. Probably you can find something like before, I guess, I don't know. But I think that we have a hype of a static analysis. I think now we have a lot of good tools. But sometimes I have the feeling that, it's just a feeling, I don't know if it's true or not, that then some people think that it's kind of like recent or like it's not. But this is old. This is very old. Or at least I find it very old. Sorry if someone was born before 78. Okay, basically then static analysis. The main point is like, it's without executing the program. And here if we take it like with the strict work, we can have some control flow, we can have data flow analysis, we could have code reviews if we grab it in the sense, hey, it's an analysis that we do without executing the program. We can have manual code inspections, and so on. On the other side, we have dynamic analysis. That would be, you really have to run something. And we have unit tests, threat sanitizers, address sanitizers, and defined behavior sanitizers, memory leak detectors, you name it, fuzzing. You have a lot of ways to detect issues. And basically these issues, we can separate them, I would say, like also in two blocks, like what it is more automatic, what is manual. Like a code review would be something super manual, or for example, some of these UI acceptance tests that you really have a user repeating the same clicks every day, that also would be manual. And what we will focus today is in this part. The part is automatic static analysis. Okay, now let's go to the second part. The second part is findings. And this is something that my experience in my team or in the project that I am is that we miss something there. We miss some fundamentals. Let's start with the basics. What is a finding? This is, I think I didn't put the reference, I think this is from the Cambridge dictionary. A piece of information that is discovered during an official examination of a problem, situation, or object. Piece of information, that's what we get. We do some kind of discovery. And basically it's like during some process, something that we do, it produces a discovery. We examine something. We have some finder, examiner, you name it. And then you produce the finder. Let's go a little bit more concrete. We have code. In general, in our case, what we want to check is code. We put it through some tool or reviewer, when the automatic will be a tool. And this will end up producing a finding. Now, what the finding should contain. And this is something that you can think it from the two ways. I mean, I'm not sure how many of you here are tool vendors and how many are developers. But just consider, one important thing is where. Like, a finding is not really valuable if you don't tell me where it's happening. I just can compile my code, and my compiler can be nice enough to tell me, hey, you haven't defined behavior. Yeah, but if you don't tell me where, that's just useless information. Like, I can really don't do anything. Tell me the line of code. Tell me the variable, the function. You have some findings sometimes that are not associated to a line. It could be like, hey, your function should not be more than 50 lines long or so whatever. Yeah, but which function? Just indicate it, please, be nice. And the file, like you can have different functions with this, like the same function name in different files, maybe different namespace. Variable. If you just indicate the line, sometimes, I mean, I think we know it from some compiler errors that basically you have a long line and you need to figure out which part of the line is relevant. What? Description of the problem. I think that here we are also like good. Like, we have a lot of tools that they provide that, but tell me, what is going on? Don't tell me there's an issue here. Tell me what is the issue. What are you trying to tell me? Up to here, I think that this most of the time is there. Why? For me, like when when we have to deal with a static analysis, like, I like to know why. Like this helps also, this helps you as a developer to improve. When you can know why this is a problem, or why this is reported, or why this could be a potential problem, this helps you to learn. This is how I learned Python. This is how I learned C++. And I think it's very valuable. And also helps the developer to understand, oh, that's not a, oh, this is a stupid rule or something, but it's like, no, I'm telling you why. And you can have two reasons of the why. One is why it's a problem. Tell me why it's a problem. But you can have the other one. Why it's even being reported? Why are you telling me that? Hey, maybe because we adhere to some guidelines, and that guidelines talk about implicit cast, and then that's why I'm reporting the implicit cast, because of that guideline. This is something that it can be valuable to understand. How? This is like, do you have an automatic fix? Is it available? Could you suggest me how to do it? Give me options? This is a way to give guidance, to provide some guidance. Another thing that is useful would be like references. Sometimes you can just not fit everything in one single line, in one single error, but you can provide references that the developer can check or not, but you have it there if you want. I don't know, maybe you even have a YouTube video link, whatever, check for it. And contact. This is something that we also found, this probably it's harder with open source tools, but especially when you have the setup in your organization. Who can I ask for that? Like, not everyone here, probably like most of us, we are kind of C++ experts. We will not start asking from 0 to 10, but more or less experts, but most of the developers are not like super experts. And they might want to discuss it with someone. It's good to provide some kind of contact that in your organization you have a way to say, hey, to who I contact. And the second part is like how I report false positive. Maybe I believe that this is a false positive. I want to be able to report it. Now let's go on the direction on the findings. We said we have a code, we have a tool or a reviewer. And now basically comes the question, is the issue reported, yes or no? If yes, that's what it's producing as a finding. And now this finding, we can say, is this correct or not? And that's, if it's yes, that's what we would call a true positive. If we say no, then that's a false positive. And now basically it's like, if the issue is not reported, and this is something that then it's like, it's a no finding. Now here you can still ask yourself, is this a finding? Yes, and this would be a false negative. And if it's not a finding, that would be a true negative. And very basic, I know, but let's build on that. What do we do with true positive? Here you have multiple outcomes. That's not just one simple outcome. You can fix the issue. That's the most trivial one. You could just suppress it. You could say like, but why it's fine? Like, yes, this I know, this might be, maybe it's a potential issue, maybe it's not an issue, and maybe you can justify why for these cases that would not be a problem. Maybe you have a rule that lead to that finding. You have a MISRA rule that was written in the 90s that you have to follow. You think it doesn't make a sense. Maybe you can just go there and try to change the rule and say, hey, this is not a problem. Let's change the rule. This is something that you can do. For the false positive, you can report the false positive to the tool, to the reviewer, saying, hey, this I think it's a false positive. You might be surprised on the outcome. Maybe you think it's a false positive, but from the discussion you figure out it's not a false positive. You can just suppress the issue. Apart from doing that, just suppress it, explain why it's a false positive. You should try to give some argument there. And this is the last one that I see a lot of times miss. You could create a test like to detect the false positive. You want to know when the false positive is fixed. You don't want to end up having code in your code base like, yeah, suppress false positive, suppress false positive. When you plan to do the cleanup, when do you know that the false positive has been fixed? Do you go over the code base from time to time and remove them all and check again? That would be a bit annoying. It's better if you can selectively know when this is fixed. And now let's go for the false negative. The false negative, I don't know, how many of you really consider false negative? This is something that I think as a tool vendor, you consider it more, but as a developer, it's something like, I don't have an issue on my code, like then everything is fine. But for me, sometimes it's happened. It's like, yeah, you review a bug, like, I don't know, you are investigating a bug, and then you figure out, I don't know, maybe this variable, it's initialized, or you realize that you have a race condition or something, and then it's like, wait a second. Like the last year I was setting up thread sanitizers, UV sanitizers, I have my Clang tidy, I follow all the MISRA, and this was not reported. This is something that it's good to think about. This is the way that brings us forward. And especially for safety critical systems, at some point this will be important. You need to be able to justify that your tools are checking for what you are saying that they are checking. This would be part probably of a tool qualification. This is something that most of the time you will not be involved. But this is valuable feedback because it may be that the tool qualification kit or it misses some use cases that you know, or maybe you just misunderstood the rule. What do we do in this case? Check if this is an issue according to the rules. Maybe you believe that it's an issue, but we have no check for that. I saw like, hey, people are using Westcons. I mean, what the fuck? This should be an issue. Oh no, we didn't agree that we should Eastcons. Check your rules. You might have to adapt the rule or the guideline. If we say, hey, this is an issue, but maybe I don't have a rule, let's adjust the guidelines in order to issue that as a problem. You can report that as a false negative. I'm not sure like if some of you told vendors if you ever received that, but it's like, that would be like, I think it's really valuable. But I assume that they receive much less false negative than false positive reports. And the same, like create a test that detects when this false negative is fixed. I think that this is also valuable to say, hey, now I can really rely on this fix because all these cases that were not covered, now they are covered, and maybe you can just, if you had 2 tools or something, then, I mean, you know when you are improving your quality. And the last one is the true negative. Nothing much to say. I think like it was not found, it's not an issue. I mean, if you can have another idea of what you should do. Yes, sorry?
For the false negative, isn't there more low-hanging fruit that you have not configured your tool correctly?
Okay.
So there is an option in the tool, and you should enable and check for exactly the issue you have.
True. That could be. I consider like about adapting the rules, but it's true. Like it could be that more than adapting the rules, you should adapt the tool configuration. That's a good point. Yeah. I think even it could. Going that path, I think you can also consider with the false positive. Sometimes some rules, maybe you need to specify, hey, which version of the language I'm using or stuff like that. Apart from the rules, this could be. Probably I should add the tool configuration in the different places. And yeah, basically the true negative, like nothing to do. Everything is fine. Okay, now we had the first part. Now let's go to MISRA. Okay, MISRA, funny enough, it's like, I'm not sure how many knows what that means, but basically it's Motor Industry Software Reliability Association. I don't think it makes more sense anymore. This is historical. This comes from the early 90s when they were developing guidelines for road vehicles. Like you didn't have, that was kind of like the reason. Nowadays it provides, I mean, it started mainly like with C. Nowadays provides guidelines for safe and secure applications, C, and also C++. Also other guidelines that I will not discuss now, like modeling frameworks and stuff like that. And the 3 publications, or even the 2 that I will want to focus today are these 3. Like, first one is like MISRA rules for C. That, by the way, there's the 2023 version since July, maybe, something like that. That basically is for C11 and C18. The MISRA C++ 2008, yes, it's called 2008 and was done in 2008, and it makes you use C++ 03, 20 years old right now. And basically you have the MISRA Compliance 2020. I would be interested, how many of you know about the MISRA Compliance document 2020? Not too many. That's okay. Then that maybe then that's good. That's good. For this one, yeah, we'll talk about that. Here you can find more about MISRA. As I said, it's like I'm an individual. I'm not here to come to announce like, oh, we have new MISRA guidelines. Sorry for the disappointment. Now you can just open the door and leave. I will not prevent you from that. Let's discuss a bit why MISRA. I give you a second to think if you want why you want to follow MISRA. Basically, like I'm not sure. Like here, like I mean, there were a lot of hands for MISRA, but how many of you are like in fields that is not like automotive industry and you follow MISRA? That is not. Okay, quite some hands. Yeah, because basically, like in automotive industry, we have this ISO 26262, very easy to remember. That basically is like for functional safety on road vehicles. This kind of a specialized standard from a more generic one, and basically like there are different versions or similar standards like for nuclear power plants. I think there's one for aviation, for medical devices, maybe some other, just focusing a bit on different fields. And in the company, we have to follow 26262. This for functional safety. And this standard has some interesting paragraph here that basically it's like kind of forcing us to use something. Criteria for suitable modeling, design, or programming languages, C 5.4.2, that are not sufficiently addressed by the language itself shall be covered by the corresponding guidelines or by the development environment considering the topics listed in table 1. This would be the paragraph like this, like this ISO is split in several parts. Part 1 that's introductory, the rest that I find them boring and I don't care so much, and the part 6 that is like for the software development. I mean, if you are a software developer, the one that you are interested, it's the 6 mainly. And there you have this paragraph that is the one that kind of like forces us or like tells us, yes, you should use guidelines. C++ doesn't address all the problems that you could have. And what do we have here in this table? Enforcement of low complexity. I mean, if you have less complexity, usually you have less bugs. That's proven. Use of language subsets. We all know that some things, they should not be used. And enforcement of a strong typing, better typing system. Usually it leads also to less bugs. Kind of defensive implementation techniques. Well-trusted design principles. An ambiguous graphical representation. Use of style guides. Use of naming conventions. And concurrency aspects. Whatever concurrency aspects means. Let's say that we should take about concurrency. Yes, we have problems there. Okay, and now basically like, okay, we saw MISRA, we see the ISO 26262, and the thing is that MISRA was created before the ISO 26262. It was The one that I know of is like from 2018, the 26262. I think that there was another version from 2011, I think. But I think that 11 was the first one. I'm not, yeah, okay. I see someone nodding. Okay. And then, but basically we said, like, MISRA comes from the 90s, and people start using that. Then it's like, what do you keep using? You keep using MISRA. Or you provide me something better. Okay, someone tried to provide something better because people didn't want to develop with MISRA anymore. I'm not sure how many of you that are here that are not out on automotive, you follow the AutoSAR guidelines. That would be interesting. AutoSAR, it's like, AutoSAR is a consortium of different companies, and basically it's to develop a platform for automotive. It's let's say you have the software, like the high-level software that you might have, like, I don't know, trajectory planning, object recognition, whatsoever. And in the bottom, you have the operating system. But in the middle, you have a platform. And this is what AutoSAR defines. The thing is that in AutoSAR, you have classic AutoSAR, that's mainly C, adaptive AutoSAR, that's C++. And adaptive AutoSAR, like, I mean, if you say someone like, yeah, you need to program in C++ 03, please no. There are a lot of good things from 11. Just we can discuss if 11 or 14, but not pre-11. And they came up with some guidelines. A lot of them come from MISRA. Some are adapted. Some are like just directly linking to MISRA. And this is what we are using, and this is what a lot of people are using. In reality, you end up checking for both, for AutoSAR and MISRA. The interesting part is that also, like, yeah, I guess, okay, I'm not sure what I will claim now. Just take it as my opinion. But I guess that people from AutoSAR were like in a hurry. It's like, hey, these people from MISRA, they need ages to do that. We want to do something. We create some guidelines. They created some guidelines. But you don't want to have two different groups. So, by the way, we have the core guidelines, the C++ core guidelines. Of course, they are not for safety critical system. We have the MISRA guidelines, and now they appeared the AutoSAR guidelines. Thanks God, they decide, okay, AutoSAR already has some statements. You can check the latest versions that says, these guidelines will get replaced by the new MISRA whenever that happens. We already have some information. There was some public review of MISRA. We received a lot of feedback that was really nice. And the new MISRA is based on C++ 17. That's also good. At least like it moves us forward. Then it's like there should be no excuse to not use 17. Apart from probably use a compiler that doesn't support 17. But at least you can push your compiler that, hey, you have some rules here. And that's a reason why to use also MISRA. If you want to know more about MISRA, what is coming, there are two talks. Both are people participating actively in MISRA, one from Peter Sommerlath, one from Loic Julie, and yeah, you can take a look. If you are interested in new MISRA, I can only say one thing: stay tuned. It's really now it's soon. Okay, but now I want to talk about how the MISRA document is structured. The thing is that, okay, a lot of you said that you work with MISRA, but you can deal with MISRA in two ways. One is like you read the tools that are coming from your tooling, or you grab the MISRA document and you read it. How many of you have access to the MISRA document and can read like the full MISRA document and not just the rules? Not a lot. And that's interesting. Why? Because in the MISRA rule, there is much more than just rules. This is the index of the MISRA document from 2008. The 23 will be similar, but basically you can see here like background, vision, scope, using MISRA C++, introduction to the rules, rules references, and some appendix. And you have only one section that is rules, and then this section has some subsections. Why I'm saying that? I mean, if you are just finding your issues, finding the rules, you fix them, and you don't wonder like too much, that's perfectly fine. But if at some point you think, hey, this is stupid, this doesn't make any sense, it's impossible to have all the issues, it's impossible to have it 100% safe or whatever, I recommend a lot that you try to go to whoever in your organization. Please, I want to really read the rest, because there are some very interesting parts there that give you a little bit what is the intention. Probably just don't start reading now, just wait a bit, get the new one, and then just read it. But even in the part of the expressions, basically like there is some weird mapping. Basically you see 6.5.1 is not there, but it has its reasons, some mappings with the standard. It took me some time to figure out, but basically like it has some kind of mapping with the standard. That's why the jumping numbers. I'm not sure if it's explained, I just got to know recently. But basically it's like each section has a group of rules, but also the sections have some introduction, and these introductions, they are, I would say, like quite good, and they give, in my opinion, much a better overview and much more understanding than just the rule themselves. And that's one thing that I want here, to raise awareness that this exists. Now let's go more to the rules. What the MISRA rule contains. And this is a bit of a mix between, or a join between 823. Okay, but this, I think that all the sections will be there in 23. Rule itself, what is like, don't do that, or yeah, like kind of like one headline. Okay, I see that here the one by one didn't work. Rule category, like is it the rule mandatory, is it required or advisory? This is like different levels to say how bad or like how strict you should be. Decidability, this is something that is coming. I think it was not there in the 2008, but it's like from the people that wrote the rule, you already make a statement saying, I believe this is decidable, or I believe that this isn't decidable. In this way, it puts kind of everyone on the same page. Also the scope. This rule is like single translation unit, or you need to have the whole system. I mean, don't violate the one definition rule. I mean, you cannot do it on a translation unit. That doesn't work. You have references to the standard, like every rule, or most of the rules, they have references to the standard. They have an amplification. Sometimes it's like, we'll see later what it is. But basically it's like you have one headline, and then basically sometimes this headline implies a lot of things, and then in the amplification you list, don't do that, that, and that, or yeah. It's kind of to have short version and long version of the rule. And this is also important because some people just might read only the rule, but there's an amplification to read. There's the rationale. That part is the one that I love the most if you want to learn a language, because you can learn why someone decided to put this rule. What is the reason for that? And if you at some point want to challenge and you want to say, I think this rule is bullshit, well, go there, go to the rationale, and if you want, then start challenging the rationale, or but grab the rationale, because without that you can really not challenge anything. An example I find it extremely useful. Some rules are super easy to understand. That's the sentence, done. Some rules, they might be written for mainly tool vendors, and it's hard for a human normal developer to understand, but then you have an example. Yes, sometimes the example might contradict. Please, if that's the case, just report an issue. But the example, I find them super useful to really get an overview. And basically, you have references to other rules. And this is also especially important because you can say, oh, yeah, okay, this I fix it, and then you fix it, and then you are violating another rule. That's something extremely annoying, but it's like that. When you have a set of, 100 rules or something, it might get relatively easy that when you try to fix one rule, then you violate another rule. Okay, this for what MISRA rules. But now I want to talk about the compliance document. And I think that this is probably the interesting part for what I saw that here people are not aware of that. I was also not aware of that. I'm not sure where is the communication channel that failed on that. Maybe it's because only the FUSE experts read that part, but I still think it's super important for the developers, at least one part. As we said, MISRA has different publications, C, C++, and this compliance document. The compliance document is the one that I want to focus right now. And basically there are two parts. Like the compliance document is like it's about achieving compliance with MISRA coding guidelines. At some point you want to say, I'm compliant according to MISRA. And that document is the one that guides you. This is the part that probably it's more relevant for whoever is in the safety team in your organization that needs to do all the bureaucracy, saying yes, 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 we are compliant because we follow. But we'll see that there are parts that are relevant for us. And the important part is that this document is for free in the page. Like you just can go there, there's a PDF, you download it right away, no login or anything, just go there, download it. And it's short, 20 pages. It's short, easy to read. I mean, you can read it like, yeah, in half an hour maybe. And what do we have here? This is the content, introduction, software development process, fundamentals. The part that I want to focus here is the deviations. Now, if we just remember what we talked about before, false positive, false negative, all of this, you might sometimes say, or even the true positive, and this is more for the true positive, where you say, this is an issue, but I have good reasons, or something like that. This is where this part comes into place. And this is where it explains how you can justify a deviation. And now here I just want to try to build some intuition. I just don't want that you take my word, like my words like one by one. It's about just intuition. And then later you can just double check with your safety experts and the document. But I think the first step is to get an idea. Okay, justifying a deviation. This is something that appears there, that's one of the parts, and says some of the cases where a deviation must not be permitted. And that is something that as a developer I find it super useful, especially when you review it, like deviation needs to be reviewed also. But when should I accept if you come to me with, hey, this is fine, should I accept it? No. This gives some guidelines. Simply to satisfy convenience of the developer. We all have seen rules like, yeah, don't have more than 20 lines in this function. Yeah, but now I have to refactor. This will take me like some days. Yeah, it's just too much work. No, that's not a good reason to deviate, sorry. Here you can just think what it means convenience of the developer, but you get the idea. When a reasonable alternative coding strategy would make the need for a violation unnecessary. We had a clear example here. We used one tool that I will not mention the name, that for some reason that I can imagine could not understand isconst. It could only understand westconst. Every time that you had isconst in your code was triggering a false positive. And there we had two options. We are stubborn and we stay with isconst and we suppress it. I'm an isconst defender. I don't see any reason why we should not use isconst. Or we just say, you know what, we go to westconst. And I'm the bad guy that had to say, hey, I mean, according to this, what it makes more sense is we stay on westconst. Honestly, like the cases where isconst or westconst makes really a difference when you read it, we don't have so many. And here was clear. We had a clear alternative that was we move to westconst and then suppressions are not needed. This is how I interpret as a reasonable alternate coding strategy. You can just grab examples. Again, this is not very precise, but it's the idea what is important. Without considering consequences. That's important. Like, all rules are like done in a way, but also like sometimes MISRA will not contain a rule just because you know that if you follow that rule, then you don't have to consider that. But in the moment that you start violating rules, let's assume for a moment that there would be a rule saying don't use exceptions. Well, I mean, like, if you decide to violate that and you would decide to use exceptions, well, that might have some consequences. Maybe you have to consider some other rules to adding, or, yeah, just consider the consequences. A process, that's also something that it requires here. You need to have a process. It cannot be that, yeah, you know what I mean. And also, like, without the consent of a designated technical authority. You have one junior, I mean, really, like, all respect with juniors, but let's say, like, I mean, like, I'm junior on some topics, I'm senior on others, right? I mean, like, we are all juniors and seniors at the same time. But doesn't make sense that someone that is a junior on a topic, then like, oh yes, I deviate, and then another junior on the same topic, it also approved that. We should end up having some kind of technical authority. And these are the things that, yeah, they appear onto the document, and basically we should follow. Again, full information, just go there. The document is 30-something pages. If you cut the appendixes and stuff like that, it's around 20-something pages. Okay, let's go with an example of a MISRA rule. Yeah, I'm not allowed to copy-paste. I just put it like roughly. We have a rule, do not abruptly terminate the program. And now here, like, what does it mean? Okay, we have an amplification, and this amplification could be something like do not call abort, exit, or terminate implicitly or explicitly. Now, maybe someone can answer, why this is not, like, why this is something that you would like to forbid, like, as a guideline? Then you can discuss if you want to deviate or not, but yeah?
Sometimes it's hard to determine that something has stopped working if you're in an embedded environment, especially.
That could be a reason. Is the reason that MISRA chose? Who knows? Well, we have the rationale. Basically, the rationale is that in some cases, like, stack unwinding is not happening. In other cases, it's implementation defined. For example, in abort, if I remember right, in abort, it's not happening. In std terminate, it's implementation defined. And that's something that, yeah, well, I mean, if you had some resources taken, maybe you end up leaving some file open. Will your operating system do the cleanup? These are things that you should consider. And that's the rationale. And that's good to know why the rule is there, especially because when you deviate. This is just a bit of a simplification of a rule that exists. If you want to know the exact definition, just check it onto the document. It's more to get the idea. Okay. Now let's. I think we're quite good on time. Let's check an example. This code. Let's assume like you have this code, and basically it's like you have a tool, and the tool tells you like in this line std terminate. It's a finding. Is it correct? I mean, I would say yes. I mean, it's quite hard to say it's not correct, right? I mean, like the rule was about that. It's saying it's correct. But is it something that we want to have? I mean, if you look at how it looks like that, this is kind of a contract style, you know, like I have some preconditions. I decide maybe that my function, I don't want to divide by 0 to integers, and I want to just catch that in case that happens, and I will do an std terminate. Maybe it's like, it's fine. Like in my project, it's fine. Okay, then let's suppress it. We have some ways to suppress it in a tool that it's, you just write ignore finding. Okay, I write this, and then I go home. Perfect. Is it fine? I mean, like, I mean, this is not fine, right? I mean, like, yes, I mean, ignore finding and what? Yeah, I mean, you should say something, right? I mean, if you have a comment, you should put something. I've seen this in code. honestly, I've seen this in code. What does it mean that it's fine? I mean, why? Please tell me. I mean, some elaboration. That's of course not fine. Did you decide on your own? Like, did you check with someone? Yeah, let's solve it. Yeah, we agreed it's fine. Okay, at least now you know that 2 people decided that this is fine. And they decide to accept it. Perfect. Yeah, but again, like, I mean, honestly, like, I know it's a bit annoying, but we are developing safety critical system. I mean, if for you it's not important, then maybe just you should consider if you really should follow safety critical system rules. I mean, at some point, like, maybe you don't want to apply MISRA to some UI, and if you do it, it has some consequences. I mean, yeah, just think about it. This could be probably something better. The project agreed to address precondition violations with a call to terminate in, and here we put some reference. You can read why it's not a problem if the stack is not unbound. I just don't want to say if this is really right or wrong, but at least if I see something like that, then it's like, okay, now probably I can start considering if I approve it. Honestly, the other ones for me just simple. I don't even have to think anything here, like request changes. I mean, it's just simple. In reality, like, I mean, but if you see here, the idea is like, okay, again, it's about building intuition. You explain a bit what you consider part of the rationale. You put maybe some link to not clutter too much with information. You can find like in this document, you can find an example how should look like a deviation. It's much more complete. You have much more text, but you can get some idea. Here, the important part is the idea. Now we have another one. We saw false positive, false negative. Let's find this piece of code. I've seen these kind of things. You have this code, and it's like, hey, I'm triggering your finding on the first line, and I'm triggering your finding on the second line. Is this correct? Is this a false positive? Let's start with the first line. Is this a false positive? Yes, I see a yes. Someone that says no? Someone that says maybe yes, maybe not? It depends. Okay, and for the second one, like, is it a false positive? Okay, what if I would tell you that before there's some code like this one? Like if like I mean, this, you put this on top of this. I mean, if that would be the case, like, the first line is not really a false positive, right? I mean, like, it's like, that is fatal in reality, it's calling an STD terminate. It's like, that line is really terminating. That's why this is something that it might become a problem. In the moment that you have some tools that produce too many false positive, the developers start hurrying on saying like, oh, this is a false positive. But when you check false positive, you really need to double check. Like, there are a lot of things that can happen. And that's what I just wanted to illustrate here. Thanks God, this didn't happen. This is not something that I took as an example from code. But it goes along these lines. Like, there are things that you assume that, oh, yes, it had the word terminate. They did a regex to find all the calls to terminate, and that's why it triggered. But maybe the tool was smarter than you thought so. And this is something that it would help you also, like, when you report the false positive, that someone maybe would double check. Yeah, basically, then you could just suppress it, but of course, like, if you put then suppress false positive, then in the first one, that would just be wrong. Okay, that's what I wanted to tell today. But basically, like, now let's check what I would like that you take from this talk. As you saw, it's not about the rules. Don't fix things without thinking. And this, I think, is like, it's a favor for you. Like, every time that you have to find you have a finding, don't take it like, yeah, now I have to fix findings. No, just take it as opportunities for learning. This is really amazing. Like, oh yes, you can say to your manager, yeah, I need to fix this finding, it's really hard. And then you start reading the rationale, you can check the standard, why this is a problem. Just don't fix without thinking. Don't suppress the finding without thinking. We saw an example. You can have similar examples. Keep in mind that false negative exists. This is something that you can do. Like when you are reviewing code, if you see something that you say, hey, this I think it's wrong, but it's like, hey, did you have some tool triggering that? You have all the checks passing and you still think that it's wrong? Maybe consider. This will help a lot to improve your development environment. And also, like, fixing or suppressing is not the two choices that you have. You can report false positive, you can adapt guidelines, you can actively contribute to guidelines. Really, like, in the MISRA working group, there are people that they were super annoyed of the old MISRA rules. And some of them, instead of just complaining, shouting, and saying MISRA sucks, they just went there, they joined, and they put a lot of time and effort to make that better. And that's the only way. And of course, it's not easy. Like we might spend, I don't know, like for some rules, we can spend hours and hours and hours, and you just count that there are 100 rules. But you have more options that fix and suppress. And this is something that you should keep in mind. Don't stay like this narrow-minded. That would be the talk. Thanks to everyone for listening, and I hope that you enjoyed. And if you have any further questions, please. There's one hand there.
Thanks. Is there a distinction between suppressing and deviation?
Yeah, when I say suppressing in general, it can be a deviation, because if you do a deviation, you don't want that it appears anymore in the report, right? I mean, usually, like, if that is fine, you will add some kind of like suppressing mark that you say, this is fine. And it's like a deviation, because you can suppress because it's a false positive, or because it's you want to deviate from the rule. That would be the difference.
Yeah, so to rephrase my question, the deviation would be the terminology for only for false positives. No, sorry, for true positives.
Exactly, for the true positive, where you say, yes, for whatever reason. I mean, you have, in the document goes a bit more in detail, because you have sometimes like, this is definitely an issue, or this is a potential issue. Imagine that this is an issue depending on your input, but somehow you can prove that the input will not be in that range or something like that. And then in that case, you need to say, this is fine, and you want to suppress it, and how you suppress it through a deviation. But sometimes you want to suppress the warning, because that's a false positive, and then you suppress it to in a different way that is not a deviation. I would not have a way to, or a word to say how you suppress it for a false positive.
Okay, got it.
Yeah, thanks for the talk. I can only emphasize what you said about the suppression comments, that there should not only be a second opinion on that, but also a, let's say, capable second opinion. And just as a funny story, a colleague of mine at Bosch even trained an artificial intelligence model to read all the suppression statements, whether they at least sort of make sense or whether it's just total bullshit to shut the tool up.
I have pending to do a regex, because some of them, like this type of, it's okay. Even sometimes people copy paste them, and that's even making it better, because then it's easier to search for them. I mean, at some point you try to go by steps, right? Like, I mean, you cannot go from 0 to hero. You try to get something and then get better. But we had cases like, yeah, people that believe in the expert. I mean, probably most of you, you know, like u in 16 plus u in 16, what value give you, if you can think about that. Yeah, some people say, no, there's no conversions going on or whatsoever. Like, yeah, I mean, and then they read the style, it's like, this cannot be true. It's like, yes, sorry, it's true. That's why we have a rule.
Right, just one comment from my side also. As a difference to AutoSAR, for this bugging is actually the copyright. So we have like findings, hey, you violated a rule, but we cannot tell you. You cannot like populate examples which are good or so. It's just not allowed.
Yes. I cannot say anything else on that. I find it, I mean, for me personally, I don't like that it's, I mean, honestly, like the MISRA guidelines to buy, they don't cost so much. I mean, I think like one copy of the PDF costs like £15 or something like that. It's not really expensive. But usually, like if then you are in an organization, even like, I don't know, depends on the organization. Sometimes it's hard. But yeah, I mean, that's a, yeah, I agree.
I mean, with AutoSAR, we can just, you know, put them on an internal web page or even deliver with a tool, everything fine. Developer has a finding, clicks here, okay, cool, I know what to do, but MISRA, no. We cannot tell you what you did wrong.
Yeah, I agree.
So speaking specifically about the manual review process for code review.
Yeah.
So you had all these like suggestions for like, okay, what, why, where, how, links, references, whatever. Like adding all these steps like as guidelines for manual code reviews, don't you think that the like developers are doing the code reviews like will either like do a worse job just because it's gonna be like it's gonna take more effort to go through a code review, or yeah, just maybe say, okay, this is a finding, but it's minor, so I don't even want to report it because it's going have to go through all these. I have to open a Jira ticket. I have to, yeah, you understand, I hope.
Yeah, I mean, I like your thinking because that's exactly how I wanted to structure the talk, because the first part you can apply it to almost any findings. And yes, I mean, I agree with you that it's like, that's why for me, I would never enforce that. Like you can give that information. Some people might not have thought about this information that you can provide or that is valuable. But I would never, I really hate enforcing things because usually things go wrong. Like people find ways to go out. And for code reviews, my experience how it usually works is like you have someone starting, you know the level of that person or like how much have been in the project, you put some effort, and basically depends on what that person makes with your comments, you decide what you do in the next review. Because at some point when you have been explaining very detailed and a lot of information, and you see that that person is not learning, then maybe I will just not put the effort. One thing that I did for some cases, you end up seeing a pattern. There are some things that people end up doing wrong. And for me, one way that I speed up reviews, but still keeping quality, is like I have a kind of a preset of answers. Even sometimes I can add a comment saying, hey, this is like a copy paste that you know, but a lot of times this is really useful. And even for the person that is writing that, and sometimes I can answer, no, this is about something else. Okay, sorry, like I mix up that, right? But this, I think it's a way to improve that. But I would never enforce, yes, you need to provide all of that. I mean, no one will want to review code.
Okay, thank you.
So there was, I mentioned, I'm curious, are there any known efforts to have tools that are capable of actually fixing MISRA warnings in an automated way?
Anyone here? I mean, I don't know. I mean, like in some, it's like, probably you don't want that some tool automatically deletes the SE terminate line, right? Because, I mean, probably you wanted to do something there. The autofix, like, I put it there because it's something that it's like you should consider, but it's always dangerous. I've seen autofix with client ID that someone says, yeah, you apply the autofix, and I find it super useful, the autofix, but then for me, you need to really pay a lot of attention on the reviews. And an autofix without proper review, I find it harming more than helping, because at the end, you don't have the issue being triggered anymore, and no one check if the fix was really a fix or like, Yeah, I see it like with data types. Oh, you have an implicit cast. Yeah, make it explicit. Yeah, but maybe you are losing data. You just make it explicit, and you lost the opportunity someone to see it.
Just to comment on that, if you have some whatever AI-based assistant to maybe ideally get automatically rid of the warning, in this safety critical context, you would have to tool qualify that AI, and good luck with that.
Yeah, hello. Thank you also for the talk. I have one question regarding not only quality checkers in static code analysis tools. Do you also working together with another department maybe regarding security issues? And because my current understanding is that with MISRA you can only detect quality issues, but not directly security issues.
Let me see if I find. And secure. The thing is that, I mean, I'm not sure, like, for what I understood, like, I think MISRA at the beginning didn't really consider so much the secure part. At some point they did a conscious decision, and they also referred to some of the CERT rules, but it also targets that.
So we have one question from the internet. How often do you get findings that suggest safety over performance and brings runtime overheads?
Yeah, that's a good question. I mean, I don't have numbers, but also most of the time, like, I mean, I might have had some claims of someone telling me that, but most of the time it's like, I don't see proof also of the performance overhead, because yeah, it can be like, yeah, an instruction more here, but it's like, what is that instruction given the overall? And honestly, in safety critical systems, at some point it's like, yeah, sorry, I mean, it's performance is not the priority. Of course you want to have it, but it's not the priority. Like.
Yeah, thanks again for the talk. I think we're done.